Achha, now what's over here is that they're saying that this over here is the overall reaction uh, for photosynthesis. So that's your overall reaction, right? Um, and he says that water is oxidized in this process to the following half equation. So this equation over here is your oxidation half equation. So and that's your overall equation, this one over here. I said, so what did we, and he's saying that use these equations to reduce the half equation for reduction. Okay, that's what they're looking for. So it's kind of the reverse, right? What we studied was that like if I go back and we do all the reactions, you have all these half equations, right? For example, all these reactions that we did, like let's pick the simpler ones that we did earlier. So all these reactions that we did, for example, this one, right? You had the lower one losing electrons, the higher one gaining electrons, right? So it was oxidation equation plus the reduction equation, and you got your overall equation. Is that clear? So basically you had this thing going on, which is you can write it in equation form. That's oxidation equation plus your reduction equation, and that's equal to your overall equation. ठीक है, Varda, is this clear?
Yeah, it's clear.
But the equations would get multiplied by a certain number as well, right? So for example, this one is getting multiplied by A and this one is getting multiplied by B. Why? Because you would have to make the number of electrons gained and lost equal before you added them up, right? So the question states that they've given you the oxidation equation, they've given you the overall equation. So how would you find the reduction equation? So it's simple. It's basically the overall equation minus the oxidation equation. Whatever is left, that's your reduction equation. Okay? Is that clear? Well,
Yep, it's clear.
But remember, the oxidation equation is going to get multiplied by a certain number, but we can't decide what that number is. Why? Because we don't have the other equation, but we have the overall equation. So from the overall equation, I mean, I can actually guess what that number is. Just if you look at this equation, like you don't need to know that you got multiplied by 5 because you can see 5 in the overall equation, right? So even if you don't write 5 over here, you would know that this equation got multiplied by 5. That's why you're getting 5 over here, okay? So if you look at these two equations, you would know that this number, can you guess what this number is by looking at the overall equation? Varda, can you guess what that number is?
Is it 3?
Why do you think it's 3? Because there's 6 H2Os, right?
Yep.
Yeah, that's possible, but there's O2 as well, right? And remember, in the oxidation reaction, what is the species that is getting oxidized? It's oxygen, right? Because oxygen is -2, and here oxygen is 0. So I think the species that we should focus on is balancing out the oxygens. And I guess the way you're gonna balance out the oxygens is that you would have to multiply it by 6 because you're getting 6 O2. Okay, the oxidation part is the oxygen over here. Do you get my point?
Yep.
So I think it's better to multiply it by 6. Okay, oxygen is the species that is getting oxidized. So you need to make that equal in the overall equation. So all I'm going to do is I'm going to just subtract this from the overall equation. Whatever I'm going to get is going to be my reduction equation. So what do I get on the left-hand side? It's going to be 6 O2 plus 6 oxygen. Okay, so 6 O2 plus 6 oxygen. So what do I get? It's going to be 6 O2 plus 6 oxygen. So what do I get on the left-hand side? It's going to be 6 O2 plus 6 oxygen plus 6 oxygen. So what do I get on the right-hand side? It's going to be 6 O2 plus 6 oxygen plus 6 oxygen. So what do I get? It's going to be 6 CO2. ठीक है, so overall minus oxidation. 6 H2O minus I think 12 H2O, so that will give me minus 6 H2O. ठीक है, I had 6 H2Os over here, I had 12 H2Os over here, so I'm going to get minus 6 H2Os. What's on the right side? Glucose plus 6O2, so that's the O2 will get cancelled out. 6O2 minus 6O2, so that gets cancelled out. So C6H12O6 minus 24H plus 1 and minus 24 electrons because the whole equation is getting multiplied by 6. So I'm going to get this, and that's basically my reduction equation. The only thing now is that you don't write equations in this form. In chemical equations, you don't have minus. So chemical equations are like math equations. So you can just get rid of the minus signs by rearranging it. So I'm going to keep 6 CO2s over here. I'm going to bring the minus 24 and minus 24 electrons to the left side. So that's going to be plus 24 H plus 1 and plus 24. अच्छा, product में क्या होगा? I'm going to get glucose. So C6H12O6. And I'm going to get 6H2O. ठीक है, so that's my equation now. ठीक है, so it's this. So is this clear?
Yep, it's clear.
So the next one is draw a fully labeled diagram to the of the apparatus that should be used to measure the standard electrode potential E naught of oxygen in half equation. I mean, basically asking for drawing this electrode. ठीक है, so remember drawings were important. So it's a gas electrode with ions. So how do you draw gas electrodes? That's so there's going to be a gas jar, which is going to have the oxygen gas, and everything else would be part of the solution. So you would have, because there is, I mean, he's talking about this one. So there's H plus 1. So the solution is going to have H plus 1. That's going to be 1 mole per dm cube. So H plus 1 aqueous. That's 1 mole per dm cube. And water is obviously there. You would need a platinum electrode. Okay, so your electrode will be made out of that's going to be made out of platinum. Okay, is this clear?
Yep, it's clear.
So for the cell drawn, use the data booklet to calculate the E naught cell and deduce. As a cell, so he's talking about the full. He's saying, how would you measure the E naught? So all electrode potentials are measured with respect to a. So you have to make the whole complete electrochemical cell. So all electrode potentials are measured with respect to the standard hydrogen electrode. So you're going to draw that. This is H2 gas. There's going to be H plus 1 in the solution. There's going to be platinum electrode. And you're going to connect them together by a voltmeter. And there's going to be one more thing, which is our salt bridge. Okay, so there's going to be a salt bridge. Is this clear?
Yep, it's clear.
And you can measure the E naught cell, which is you would have to find this electrode in the data booklet. So where's that? The water, oxygen, and H+1, right? So the water, oxygen, so I think it's this one. I mean, their electrode is going in the backward direction. So it's 1.23 volts. Just this one is, so this is 1.23 volts. And that's your reference electrode, so that's always 0 volts. So the E naught cell is obviously 1.23, higher minus lower, and the positive electrode is going to be the left one. Okay, that's going to be our positive, and this is going to be our negative electrode. So we're gonna move to the next one, which is this one. So this one. So whether try doing this one. He's saying use data from the data booklet to predict whether a reaction is feasible when aqueous solutions of iodate 5 ions and bromide ions are mixed. Can you go and find an equation for bromide? I mean, there's only one equation. What is that?
Is it Br2 plus 2E minus goes to 2Br minus?
And what's the electrode potential?
1.07.
So now, remember, in such a question where they ask for feasibility, follow their instructions. He's saying that what two things are reacting? Iodate 5 ions reacting with bromide ions. So there's only one option. This is iodate 5. So that means this must be gaining electrons, right? And it's reacting with what? It's so iodate 5 ions are reacting with bromide. So that they must be, I mean, they must be losing electrons, right? So I'm just going to follow I'm going to follow its instructions, like iodate 5, so must have gained, bromide must have lost electrons. That's the only option. And now I'm going to try and figure out whether the reaction is feasible or not. So it's what, reduction potential minus oxidation potential. So what do we get as the E naught cell? Okay, difference. So that's 0.12 volts.
0.12. Yep.
So that is feasible. Anything that's positive or greater than 0, that's feasible. And it makes sense because this is the higher potential, it should have gained electrons. This is the lower potential, it should have lost electrons, right? So that is exactly what's happening. So the reaction is feasible. Okay, but remember this, that you're going to follow what they're suggesting as the reduction and what they are suggesting as the oxidation. I'm going to go with them, and then I'm going to try and figure out E naught cell. As a next one, you've got I said this is something that you don't have to do calculations. And let me just double check this one once more. Just hold on 1 second. I'm pretty sure it's not. So forget it's Faraday constant is definitely not. So remember, calculations related to electrochemistry, that's not part. So ignore those questions. Okay, we're gonna ignore this. I said this one. Can you He's saying draw a fully labeled diagram of the apparatus that should be used to measure the standard cell potential. So you got two cells. One is this electrode, and the other one is this electrode. The nitric acid, NO gas electrode, and gold ions and gold electrode. Can you quickly draw this electrode, draw this electrode? It's an electrochemical cell, so connect them together. So try and draw a fully labeled diagram, complete with labels. Okay? Send me a picture for that. What are you done with the drawing?
Yep, I'm done.
Have you sent it?
Yep.
So got it. Just 1 second. as it it's not silver actually, it's gold, right? AU is gold, AG is silver. But apart from that, I guess everything is fine. I guess that's fine. Except that you have to like tell them that this is 1 mole per dm cube, nitric acid, that's 1 mole per dm cube. NO gas is going to be at 1 atmosphere pressure. Otherwise, it's fine. Okay.
Okay.
So moving on, he's saying that so you got he's saying write an ionic equation to show the spontaneous reaction that occurs when an electric current is drawn from the cell. I mean, so what is the spontaneous reaction? So it was 2 electrodes, right? It was the first one. The equations are given, right? So it's AU and AU ions, and the other one was nitric acid and NO gas. So I think it's the third one, right? So the higher one gains electrons, the lower one loses electrons, and that's it. So it's going to be what, AU3 plus, NO gas, and 2 water molecules, and the product is what? Product is AU solid, and what else is formed? In the third equation, it's NO3 minus 1 that's getting formed, and 4H plus 1. So that's it. Okay, the electrons are already balanced, so I didn't do anything. I didn't multiply the equations. And you have to calculate the E naught cell, so that's easy as well. That's reduction minus oxidation. So 1.5 minus what, 0.96. So that gives you 0.54. ठीक है, clear है?
Yep, it's clear.
So now so I'm going to rub this off. Now the next part, ठीक है, the one that's written at the bottom, is saying that gold can be oxidized by a mixture of hydrochloric acid and concentrated nitric acid. So concentrate, and he says that is known as aqua regia, and the concentration of hydrochloric acid is 12 mole per dm cube, and of nitric acid that's 16 mole per dm cube. So he's saying explain why aqua regia is able to dissolve gold. So you've got to justify that. He's saying that gold dissolves when you have a mixture of HCl and HNO3, and these two happen to be very concentrated. So why does gold dissolve when and they were very specific about the equations that you're going to discuss. So you're saying in your answer statement, explain what effect the use of concentrated hydrochloric acid and nitric acid have on E values of equations 2 and 3. So you're basically focusing on equation number 2 and 3. So 3 has nitric acid. The first one has I mean it's got hydrochloric acid it's got Cl ions, so probably hydrochloric acid is providing the Cl ions. So we're looking at equations number 2 and 3. Now, if I look at equations 2 and 3, gold in the presence of concentrated nitric acid, then the reaction is not feasible because gold is not going to dissolve. And nitric acid is not going to get reduced. Why? Because electrons lose kaun karta hai, the one that's got the lower potential, and gains the one that's got the higher potential, which is not true over here. You're going to get a negative E naught cell. Like if you do reduction minus oxidation, you're going to get minus 0.04 volts. So that's a reaction that's not feasible. ठीक है, Varda, is this part clear?
Yep, it's clear.
So now explain to me, why does gold dissolve? What happens to if you use concentrated hydrochloric acid? What would happen to this equilibrium? Where would it shift if I use concentrated Cl ions?
Will it shift to the left?
Okay, so this equilibrium will produce more electrons, right? If you get more electrons, what will happen to the electrode potential because more electrons are getting produced. हमने क्या पढ़ा था? What happens when the electrode starts producing more electrons?
It decreases.
So let's hypothetically say that it decreases and it becomes 0.80 volts, right? And if you use concentrated nitric acid, where would the equilibrium shift? This is HNO3 basically. H plus 1 and NO3 minus 1. So this will shift forward, right? And okay, and when it shifts forward, it increases, right? So let's say its new value is 1.20 volts. Now your E naught cell is going to be positive because reduction minus oxidation is going to give you a positive E naught cell. This will be the higher voltage, higher potential, so it will gain electrons. This will be the lower potential, so it will lose electrons. So now gold will dissolve. So that's what you're going to write. You're going to write that this equilibrium shifts to the left, so it becomes lower. And this equilibrium shifts to the right, equilibrium number 3. So it becomes higher, and that's why your E naught cell, and not, I mean, you don't have to write not because it's non-standard conditions. So your E cell is now a positive value. So that means the reaction is feasible. Is that clear?
Yep, it's clear.
I said, you've got the data booklet. Calculate the E cell for this reaction. I mean, the overall equation is given. By just looking at the overall equation, which 2 electrodes do you think are involved in this reaction?
Is it copper electrodes?
No, but which one? I mean, there's a specific electrode, right? This is copper 2 plus and copper plus 1. So it's the copper 2 plus copper plus 1 electrode, right? Can you tell me what the value is for this?
Um, 0.15.
And according to the equation, it's moving in the forward direction, right? And what's the other electrode?
I2 / I minus.
TGS, so it's this one. It's 2i minus 1, and that's what's the value?
0.54.
TK. And this electrode I minus 1 to I2, right? So that means in the reaction it's going in the backward direction. So do you think it's a feasible reaction or not?
It's not, because it's less than 0.
I think it's going to be less than 0 because the one that's going to gain electrons, it's supposed to have a higher potential, which is not true over here. I mean, this potential is actually lower than this. So this reaction will not happen. So if you do reduction minus oxidation, you're going to get a negative value, which is what I think it's going to be. Okay, it's 0.15 minus 0.54, so that's what?
Mm.
Kitna?
0.39.
You got 0.39. So explain how the value of E naught cell calculator predicts the reaction. It's a negative. That's what predicts the reaction is not going to happen. Now, as a similarly, you've got the Nernst equation. TK, that's also not in your course. Now you're saying copper 1 chloride is also sparingly soluble in water. Suggest. So why did he? I said now he's saying suggest why the following reaction does not occur. I mean the previous one. Wait a second. So the previous one was with I minus 1, and that did not occur as well, right? And I said although this is not part of the question, but can you answer this? Let me just focus on this statement. Sorry. I said, just this statement. I said, now can you explain to me that he's saying in an experiment a solution of I minus 1 is added to a solution of Cu2 plus, a reaction does occur and a precipitate of sparingly soluble CuI is formed. So he's saying that in an actual experiment, a reaction actually happens, even though it's not feasible. So based on the information that's provided over here, why do you think in reality do you get a reaction? Was there any idea why you're getting a reaction in reality?
No, I'm not too sure.
So now they used the word sparingly soluble copper iodide, right? So what ions are present? Copper plus 1 and I minus 1, right? So that means it's not soluble, it's sparingly soluble. So that means in your solution, the concentration of copper plus 1 and I minus 1 is going to be very, very low. Both of them. The concentration of not really I minus 1, because I minus 1 is already part of the solution. So that we can assume that there's already a lot of I minus 1. The concentration of copper plus 1 specifically, because copper plus 1 is only coming from this thing. There's no other source of copper plus 1. All of them, they don't have copper plus 1. So the concentration of copper plus 1 specifically is extremely low. So where would the equilibrium shift if copper plus 1 concentration is low? It's going to
Shift to the right.
shift to the right, and it's going to become more positive. So maybe it becomes 0.55. So now you've got a reaction going on. Is that clear? TK,
Yep, it's clear.
So either we explain this, I think it's the same copper 2 plus copper plus 1 equation. This was 0.15 volts. And this Cl2 plus 2 electrons, that's 1.36 volts. He wants copper 2 plus 2 gain electrons. He wants Cl minus 1 to turn into Cl2, right? So he wants this to go in the backward direction. So is this feasible or not feasible?
Not feasible.
TK, so what's the E0 cell now?
Minus 1.21.
Now, basically saying that copper 1 chloride is, the same logic he's applying. Copper 1 chloride is also sparingly soluble. So that means the concentration of copper plus 1 is very low. Same thing will happen. This one will become higher, right? Its potential will increase. The equilibrium will shift forward, right? So the equilibrium will shift further forward and the potential will increase. But he's saying even then the reaction does not happen. So what's the difference between this and the first one? Like in the first one, you did have a reaction eventually when it was sparingly soluble. So why in reality would this never happen? Why can't we use the same logic? as the one with copper iodide. Okay, any idea?
No.
It depends on the difference, right? Like even if I change the concentration, the difference between the two values is a lot. The E0 cell is too negative. That means it's too unfeasible. So you can't really, but I mean, you can't really sort of change the E0 cell this time. You can't make it positive because the gap is too much. TK, is this clear?
So how do you know if it's too unfeasible or not?
But you get the idea, right? I mean, the first thing, did you get the idea that, I mean, this E0 cell was like slightly
Yeah.
negative, and that was too negative, right? So what you're asking for is that you're just asking that if there's a point beyond which you can't really do anything, right? That's what your question is, right?
Yep.
So I mean, there's actually no point. I mean, the point was actually given in the question, basically. You just had to
Okay.
take it. So there's no specific point beyond which, I mean, even in this case, like if you use extreme conditions, you can kind of make it feasible. Like you can use, for example, I can decrease this by shifting this equilibrium to the left. How do I do that? I can increase the concentration of C lines by a big margin, and I can decrease the pressure on the system. So it will favor production of gas, right? But I can make it feasible under extreme conditions. Otherwise, so basically, we just had to infer from the question. That's it. There's no specific point. Okay, less than 0, that's not feasible. That's it.
Okay.
Sure. So think about that. Try doing some more questions. We'll just try and practice more questions tomorrow as well. Okay.
Okay.
Okay. Take care.
Yeah. Thank you, Allah Hafiz.